Well, good afternoon, everybody. Thank you all for coming. This first presentation is going to focus on the topic of energy to establish the basis of the dots that we will connect later on in the afternoon with the other presentations. So I titled it Energy in the World. So what is the state of the world? Actually, the current time is the end of the world as we know it in terms of energy. During the coming century or so, we can anticipate maxima in the production of all of our primary fossil-based fuels. You've all heard of peak oil, but it will in fact be followed by peak gas, peak coal, and for that matter, peak uranium, if we choose to include that in that mix. Uranium is not usually classified as a fossil fuel, but nonetheless, we dig it from the ground and we burn it up, and it's gone. So, irrespective of the importance of climate change, we will in fact consume most or all of our fossil fuels during the next 100 years, and we have no choice but to transition our energy portfolio to be principally renewably based, something that we are already doing. So this afternoon I'm going to talk in three different topics. I don't have time to talk about peak oil, gas, coal, and uranium, so I'm going to focus on peak oil. I'm, in my second topic, going to talk about that fracking. Fracking is something that is in the newspaper every single day. There's a lot of controversy, a lot of emotion, a lot of technical issues associated with that. And it's important in a discussion such as we will have this afternoon that we talk about fracking. Mark Zobak, who follows me, will talk more specifically about that, but I'm going to talk about it in the general context. And finally, for the reasons that I've just explained, I'm going to talk necessarily about renewables too, because that is necessarily where we are going in our energy picture. And it is, as you've understood, our intention this afternoon to connect the dots between energy, environment, water, climate change, and food. And I will not do that. However, you can mentally do it as we go through the steps of the talks this afternoon. Number one, peak oil. It's widely discussed and almost as widely misunderstood. One of the reasons that people don't grasp all of the concepts about peak oil is that, in fact, there is more than one oil peak. And peak oil is used to refer to an issue described 60 years ago by M. King Hubbard, hence it's sometimes known as the Hubbard peak. Hubbard was a geologist who worked for Shell, who proposed 60 years ago that the world would ultimately decline in oil production. The two peaks, however, that we need to discuss are not only a peak in oil production, but also a peak in oil reserves. And the distinction between the two, although they are not unrelated, they are in fact independent parameters. Think of the money that you have in your bank account. Those are your reserves. Think of the rate at which you spend it. That is your production. Clearly they're connected, but they're not necessarily directly correlated. This graph shows the two peaks for the United States oil production. The United States has a particular characteristic in its oil industry in that the oil companies look for oil, and as fast as they find it, they produce it. That's the business they're in. And therefore, the two peaks, in fact, correspond almost exactly, except they are shifted by a space of about 35 years. I should point out to you, this particular slide is made by Dr. Jean Laharre, who is kind of a latter-day M. King Hubbard. He's also a geologist who works for Total in France, and I'll use several of his slides. So you can see here that the United States, at least, had its peak oil, both of its peaks, I don't know how you would make that. Both of them happened, one of them back a long time ago, and the peak in production occurred in the 1980s. This is easy to understand. Less easy to understand is if we look at the larger picture. If we look outside the United States and include the world, that includes companies not like the international oil companies in the US. It includes principally national oil companies who have a different motivation to the way that they find and produce their oil. For them, oil is a national resource that they have to husband and provide stewardship for their citizens of their nations. And therefore, finding the oil is not necessarily coincident with producing it. They can choose to keep it in the ground, something that an economic entity like an oil company could not do. So you can see that the world resources, largely speaking, in terms of discoveries, that's the green line on the left, also has passed its peak. But the argument and controversy about peak oil is largely focused on the line on the right, the pink one, and if I can point here, which you can see kind of goes continuously up to the right. Just a moment, I have a pointer here. This line right here, that one over there, that's the one that people argue about, because that line, you can see, goes continuously up towards the right. And that is an argument that people sometimes use to say, well, plenty of oil, keep it on going, nothing to worry about. The reason why it does so, again, as I mentioned, is because the national oil companies don't necessarily have to produce their oil if they don't choose to. Let me point out something, however, that everybody can understand. You'll notice, point this out particularly because these numbers are relevant to what we have to talk about. It shows both the discovery rate and the production rate. So this is a relatively old graph, but you can see in the period around 2000, the world was discovering about 10 billion barrels of oil newly every year. This is what geologists do for us. That's good. We are continuing to discover oil. However, the world in 2012 consumed 31 billion barrels. Okay, do the math. We discover 10, we consume 31. It will not last forever. This is a different graph. This is a graph produced by BP. This is the most recent figures they produced that show the current reserves of the planet. And this graph, it's different than the line I just showed you, which was production, although again, it's related. This line does, in fact, also go continuously up to the right and would appear to suggest that oil is continuously being discovered, which it is. There are some bumps in this graph. One of them here is the Alberta oil sands. We have that as one of our topics this afternoon, a breakout. Keystone XL, that is to bring that oil to the Texas oil refineries. There's similar oil in Venezuela. How then do we kind of relate this BP's line to Jean Lahare's line that I just showed you, which was a peak rather than a continuously upward movement? Well, there's a good answer to that. The point of the matter is, the reason this line continuously goes upwards, one is because we discover oil, but because, as I pointed out, we consume it at a greater rate. How is this possible? And it occurs because the oil producers actually are in a continuous state of understanding their resources. The subsurface of the earth is difficult to comprehend, and therefore, as they learn, they drill more, produce more, discover more information, they reset their understanding of their reserves. The SEC requires them to do that. They're conservative to start with. As they learn more, they update their figures. So this is discovery of reserves in oil fields which have already been found a long time ago. This is not oil found by geologists. This is oil found by accountants, okay, within companies. And if we take the oil discovered by the accountants and we move it back to the day that it was actually discovered by the geologists, this line, which is very similar to BP's line, actually goes back a couple of decades, and it's the same, the area under the curves are the same. But what you can see, in fact, by that indication, there is, again, a peak. So the peak is by no means inconsistent with the figures that I just showed you from BP. So the question then is, when is peak oil? We had it already. Peak oil has passed. If we look now at production, I talked about peak of reserves. Let's talk about production. The two are not the same. Two lines superimposed on each other here, and confusingly, they come from sources which sound alike but which are different. The IEA, International Energy Agency, is the agency of OECD that tracks many things, including the energy resources of the planet. The EIA is the Energy Information Agency, which is a similar function on behalf of the United States government. It's a component of the Department of Energy. So the blue one, which comes from the EIA, that's the Department of Energy, is actually plotting actual production. The red line is the projection of what the international community imagined to take place. And you can see they drew that line sort of up to the right, projecting that we would continuously and increasingly produce more oil to the future. But if you look at the blue line, you can see that the recent past, although there's a good correspondence upwards there, you can also notice that the recent past is a bit of a deviation from that trend. So let's look at more closely at that. These are very up-to-date figures as of last month, but only recorded through the end of 2011. But what you can see is that since about 2003, the world's oil production, including natural gas liquids, has been more or less constant at around 85 million barrels a day. A bit of a hesitation due to the financial crisis, but other than that, it's remained more or less the same. So that ever and continuously upward curve plotted by the IEA, the red one, has not at least been followed for almost 10 years. So have we reached the peak in production? Well, maybe we have. Maybe 85 million barrels a day is all we are ever going to produce as a maximum. Let's talk about why. Looking a little more closely at a region of the world of importance, Saudi Arabia, they have been producing over the last 10, 15 years at about a rate of 8 or 9 million barrels of oil. That's their production. If we look at their reserves, however, we see a different picture. This line at the top, the green one, this is known as a creaming curve. This is also plotted by La Herrera. This says how much reserves they have and the rate at which they discovered them, plotted as a function of the number of wells that they drilled in order to discover them. And the blue line shows how many oil fields they found in number. You can see it comes up to a total of 105. But looking at that graph, you can see quite clearly that, in fact, Saudi Arabia discovered most of its oil with, in fact, about 20 wells back in the 1930s. And since that time, they have added a substantial amount of oil, but nothing like what they discovered back originally. Interesting, I point out this one step here. They discovered 200 billion barrels of oil with one well. That was the Ghawar field, which now produces half of Saudi Arabia's oil and 5% of all oil on the face of the planet. That's not only true for Saudi Arabia, it's true for the rest of the world as well. If we look at how, this is the same diagram plotted for all wells for everywhere. In the 20 years between 1960 and 1980, the collective oil industries of the planet discovered about 1.5 trillion barrels of oil. In the following 20 years, however, they discovered only half of that, 750 billion barrels. The first 20 years, they drilled about 15,000 wildcat wells. This is exploration wells, not in fields that are already in production. These are sort of step-out wells. In order to discover the next 750 billion, they drilled more than 65,000 wells, 4 times as many. Message is, it's getting a whole lot harder to find oil, and it has been for a long time. Why is that? It's quite simple. They found the big ones first. It's much easier to walk into an elephant than it is to walk into a mouse, and that's what we have been doing collectively for the last 20, 30 years. Topic number 2, what about that fracking? Let's talk about that. It changes almost everything except the conclusion that I just told you. Fracking provides a considerable amount of resources that we never had before. Anybody that you would speak to who isn't lying in the oil industry will tell you it's a total surprise what has happened in the last 10 years in shale plays in this country and in others as well. Mark Zobac's going to talk about gas, and therefore I'm going to talk more prominently here in my address about oil. We have shale oil as well. It's not so commonly talked about because nobody's made a movie about it yet. But what you can see here, this again is February's figures, the yellow at the top. This is oil produced from shale resources of the type that we also produce gas from. And looking at this graph, the black line represents the current figures. The ones to the right are projections. What you can see is that there is a massive amount of oil right now being produced from shale. And that's something which we didn't see even 5 or 6 years ago. Let me, before I leave this graph, point out another few things in here. If you look back to the left-hand scale, which was 1990, 20 years ago, you can see how important Alaska was. Alaska has faded rather considerably. One of our topics for the breakouts is going to be on Alaska. You can see the brown in here is offshore, most of it coming from the Gulf of Mexico. Remember BP Macondo well, Deepwater Horizon in 2010. That's the kind of development which brought us that. The blue is the conventional oil resources, which you can see are waning away. But the big game, the big surprise here is the yellow one, shale oil. And I wonder how many of you really comprehend how significant and how dramatic shale oil has been. This graph shows only the last 2.5 years, between January of 2010 and September of 2012. And I'd like all of you to close your eyes and imagine where you were in January 2010 and what you were doing in January of 2010. Okay, you can open your eyes now. Since that time, whatever you were doing, the oil production of the state of Texas has doubled. Texas is the largest oil-producing state. Its oil production has doubled since January of 2010. And all of that production has come from shale. So its mechanism similar, although not exactly alike, those for shale gas. Technology has moved on from shale gas and is now also being applied to the production of oil. The graph on the bottom shows an even more dramatic story in the state of North Dakota. Who ever heard of oil in North Dakota? North Dakota is now the 4th largest oil-producing state. It just last month eclipsed the state of California to reach number 4. In 2010, they produced 200,000 barrels a day. They're currently producing close to 1 million. They've increased their oil production by a factor of 4. Where are we going with that? Let's just talk not only about the United States, but the rest of the world as well. In this diagram, the red represents the shale oil I've just been discussing. The yellow is other kinds of unconventional oil. So once again, that's the oil sands of Venezuela and Alberta. That's that Keystone XL. You can see how much Canada's incremental production, that's to the right, is dependent on that. You can see in the United States, we're looking for some of that as well. Actually, that comes from California. This red part is our shale oil. And you can see that many other countries are looking for that too. China, rather disappointing from their point of view, is going to lose 2 million barrels a day of conventional oil production. They're looking to substitute that with production from shale. Shale gas, I'll just touch on it. Mark Zobat's going to talk in greater detail. Shale gas is the brown line up on the top here, the band. And presently, from shale gas and tight gas, we produce more than half of the gas of the United States. So those of you who heat your homes with natural gas, which is just about all of you, half of that gas is coming from shale or tight formations. What does that mean? Try and join up or at least point out some of the dots that we will discuss this afternoon. What's happened with all that shale gas? You have burned some of it, but a lot of it went to power plants generating electricity. And the abundance of shale gas has meant that the price has been very cheap, and therefore electric utilities have found it beneficial to shut down their coal plants and burn natural gas instead, not in the same plants, but in different plants. The consequence of that is since 2006, the CO2 emissions of the United States has dropped by about 8%. So I won't say anything about that. You can understand that. Where are we producing these shale plays? The important thing about it is that they're extensive. Mark will talk about that more significantly. But I show this graph because I want to talk briefly about the Barnett Shale down here in Texas, the Bakken Shale up here in North Dakota, and the Eagle Ford Shale down here also in Texas. There's another important one here on the East Coast, which is the Marcellus. Here in California, we have the Monterey Shale, which barely shows as a kind of a pimple on the rump of these other resources. It's significant, but it's not actually that big compared to the others. If we look at the Barnett Shale, this is the granddaddy. This is the one that began it all. This is Dallas-Fort Worth Airport. This is Fort Worth City. This is Dallas City over here on the right. What you can see is how that has developed over the year. Let me see if I can make this work. So since 1982, if you look at how the Barnett Shale has developed, the black dots here represent vertical wells. In the 1990s, they were drilling vertical wells and they were producing conventional hydraulic fractures, which are the same have been used for the last 50 years. Starting in about 2000, they discovered it was cheaper, easier, and more effective to use slick water fractures, which are simply water. And right around 2005, they discovered how much better it was to drill horizontal wells, which are the red ones, which you now see spreading out over this region. Just for reference, I mentioned the Ghawar field in Saudi Arabia. The Ghawar field, were you to plot it on this map, would basically be about that big. So Barnett Shale that is shown on here is of the same sort of geographic size as Ghawar. This is the Bakken Shale in Montana, North Dakota. The difference that you see here, these spots are colored differently. The green ones are oil, the yellow ones are condensate, and the red ones are gas. What's important to show here is that it's principally oil in production, whereas in the Barnett Shale it's principally gas. Look down here, I don't know if you can see it well, but the graph shows the green here, the total oil production. If you can see the year, you can see how rapidly that has come on, how quickly it's changed the picture. There is some gas in the Bakken Shale too, but not so much. The big story is the Eagle Ford Shale, which is in the Gulf, along the Gulf Coast in Texas. And it increasingly goes deeper towards the Gulf, and increasingly, because of the greater temperatures, is gas on the Gulf side, and it is oil on the land side. So you can see here the developments of those Eagle Ford resources, principally in the condensate, which is liquid, and the oil zones. Gas is so cheap now that people are looking for liquids, which is still nicely selling for $100 a barrel. So all of these wells that you see drawn on this diagram have been drilled in the last 4 years. And I downloaded this off the internet last Friday when I prepared my presentation. The colors are not perfect on this plot, but it shows today, or at least last Friday, what was happening in the United States. The blue triangles that you see in here are the oil drilling rigs. The red ones are the gas drilling rigs. So you can see the gas rigs and the oil rigs all the way along here in the Eagle Ford Shale. Here's the Barnett Shale, and up here is the Bakken Shale, and over there is the Marcellus Shale. 1,771 rigs drilling in the United States last Friday. Pretty much all of them are drilling in shale, except the 3 green dots over there in California and Oregon, which are drilling for geothermal. So let's hear it for those guys. In terms of vertical versus horizontal, you can see once again 2/3 of the wells being drilled are horizontal. Let me skip over that. Other places have shale as well. So let me come to my third topic, which is renewables. Where are we going to get them? Where are we going to use them, etc.? This is a projection from the IEA again. This is their most recent World Outlook, comparing the big players in the energy business: China, India, US, and Europe. What you can see here, the left is what is projected to be lost in the next 25 years. You can see basically the United States is shutting down coal and replacing it with that shale gas and renewables. Europe is doing a similar thing, except they're making their replacement with simply renewables. However, what we are doing pales in comparison to what's going to happen in China and India. China itself is going to, or is projected to, produce more renewable energy than the US and Europe put together. Nonetheless, they're also looking for that shale gas too. Nonetheless, they have a massive projection for consumption of coal, as does India. What does that mean overall? In terms of primary production, let's talk about water. That's one of the dots we have to connect today. Different kinds of energy of the types that I've described, as well as others too, use different amounts of water. And it's by no means a given that, oil field operations, shale gas or whatever, are massive consumers of water. They are massive consumers of water, but you can see here many of these biofuels are also large consumers of water. These also come to our dot on food. Many of these products shown here at the bottom may also be food products. If we look at the renewables, it's a rather more favorable picture. Wind and solar consume water too, principally in their construction. Geothermal, this is a range, by the way. It goes from nothing up as far as there. Some geothermal plants use nothing, some use a lot. And then you can see the different ranges of fossil and coal and gas-fired power plants of different types. So that more or less concludes what I have to say. Let me draw your attention, since I'm not only speaking but also chairing this afternoon, as to where we will go next. We will expand on this issue of shale gas. Shale gas is so important to the picture as I've just described. We are going to make the connection to the environment, what those things mean to the environment that we will see, what it means in terms of water, how might climate change accelerate or decelerate as a consequence of what we do in energy, because the two are intimately linked. And then we'll finally end up talking about food. As you've already seen, we have in our breakout sessions topics which relate to all, sometimes one at a time, sometimes more than one at a time. And finally, we'll come back this afternoon and attempt to draw, perhaps not conclusions, but at least an underline over some of those topics. So let me stop now then and invite your questions, not about the afternoon, because you can hold those for the final panel, but anything which I have said. We have about 5 minutes for questions. Please. Let me ask you, if you have a question, raise your hand and someone will bring a microphone to you. Otherwise, the rest of the audience can't hear. Please go ahead.
Quick question. You noted a large amount of renewables projected for China. Which renewable technologies are we talking about?
All of them. So China has an aggressive program in all of the renewables, geothermal, wind, solar, biofuels. They are pushing all of those.
Thank you.
Not just in projection, they're already doing that.
Hi, quick question. Well, thank you very much for that. It was very comprehensive. So I was wondering, your analysis, does that take into consideration of potential carbon taxes globally? Because I understand that China and I think Australia is taxing on carbon or starting to as well.
Before I answer your question, I should point out this is not my analysis, but that of the EIA, and they considered multiple scenarios, some of which included carbon taxes and some of them which didn't. The one I showed you is kind of the, how could I say, the sort of the warmest, their most encouraging scenario, which does in fact include carbon tax, cap and trade, something which puts a cost on carbon. They also have a kind of business as usual scenario which doesn't look quite as rosy from our point of view. There's a question over here.
Have you examined the intersection between where the energy is being produced from shale and the concurrent water resource use, so that one could ponder, what the ramifications would be on water supply and water use through the shale development?
I have not, but others have. One of the discussions that will come up this afternoon is actually not the water use of shale gas, but the other impacts of shale gas. And there are many. There are impacts on the society, there are impacts on the environment, there are impacts on the economy. So I have not looked at that, but people are quite appropriately doing so. You know, this, as I pointed out, is a massive change of direction of where everything is going. Energy, environment, you know, society. The population of North Dakota has increased dramatically in the last couple of years. Let me take one more question because we should move on, if there is one. I have one down the front here.
You mentioned the decrease in the U.S. CO2 emissions in the last 5 or 6 years, and that makes gas look good. But apparently, if you add the methane that escapes, it turns out, to my great disappointment, that gas and coal are a wash, from what your colleague Chris Field told me a week ago.
Yes, Mark Zoback is going to discuss that point specifically, so I will leave it to him. All right, so then let me conclude and thank you for this first section. And